my name is Blessing Ekure, and I am excited to be the host for today's session. So data engineering community is a vibrant community of data professionals at all levels. So whether you are a beginner, you're an intermediate, or you are a professional, it's that community that brings everybody together, right? With the aim that people there are going to grow on with their skill sets, improve on their abilities and all of that. So there's a lot that goes on in the data engineering community, and a lot of conversations, a lot of enlightening conversations and all of that. So data engineering community is that community, and the community has been active for like the past 2 years. Kudos to our bosses at the top who have made that possible. So that is it about data engineering community. And I must say that this session will not be handled by any other person than the brain behind data engineering community. There would be no data engineering community without him. His name is Najeeb. For some of us who know him, is Najeeb Suleiman. He's the brain behind data engineering community. He's a data engineer, right? Passionate about problem solving and improving using technology. So without further processes, I would like to hand over the opportunity to the mic to my boss. The reason why we are all gathered here, hi, Najeeb.
Hello, Blessing. Yeah, wonderful. That was a brilliant, very brilliant introduction, and very good one from you, Blessing. Before I even start, I'd like to thank you, appreciate you for stepping up, even with very short notice. It's impromptu that you are hosting us today, but that's why we are an amazing community. So thank you so much for stepping up to take charge and deliver an amazing introduction. That's a very brilliant one. Hello, everyone. Good evening, good morning, good afternoon, wherever you're joining us from. It's Demystifying Data Engineering webinar series, and Blessing has done justice to introduce us properly. And without further ado, I'll just share my screen and we get started. Yeah. Please, Blessing, am I audible? And is my screen visible now?
Yes, you are audible and your screen can be seen. Yes, you are. Yes,
okay, brilliant.
See you.
Thank you so much. So we'll get started right away. To be honest, while just about some moment ago, I was thinking, could it be possible, or could we ever get to a point whereby we transfer knowledge by doing copy and paste? I think somebody's mic is currently open and causing disturbance. I'll find that person. Just 1 second. Yeah, muted. Sorry. Yeah, just have to do that. Yeah, that's better. So as I was saying, so I was just thinking, like, could there ever be like, just like in an imagination, could there ever be like us human being getting to a point whereby, by the way we transfer stuff via computers, just do copy, you paste, and just share stuff. Could there ever be a time whereby we'll be able to then do like copy and paste and share knowledge? Maybe instead of having this webinar, I'll just do like, I'll just copy whatever I have to share and just paste it into your memory, and you just get whatever you need to get from this webinar. But that's by the way. Today we'll be talking about a very important topic. We'll be talking about everything vector databases, everything about generative AI, and we're going to be demystifying a lot in the process of unlocking generative AI with vector databases. I'll move on with the slide, and I'm very sure you're going to learn a lot from this session. But before I do that, it's going to be good for me to introduce myself properly. And for some of us that are on the call, I don't need to introduce myself, but for the sake of people that are joining us from outside of the community, I'll just do like a very brief introduction. I've done this introduction multiple times, and some people are already aware of it. I'm Najeeb Suleiman, and a brief introduction about me is I currently work as a data engineer with Jaguar Land Rover UK, and the company is an automobile company, so it's a vehicle manufacturing company that is put across all over the world. It's a multinational brand, but currently I'm working with the JLR UK, which is the United Kingdom branch of the JLR. So you have many plant allocators we can. Is the brand behind all these luxury vehicles. You must have heard of Range Rover, or must have driven a Range Rover, or just sit in a Range Rover, or see a Range Rover pass you by maybe on the streets, Defenders, Discovery, Jaguar, and some other amazing brands like that. So and what we do, myself and my team, what we do is to support initiatives in terms of manufacturing, helping the company sales better, helping the company improve processes in terms of maintenance and everything that contributes to reducing costs, increasing profit, and just anything that brings customer satisfaction to our customer base. So that's what I currently work as in the UK. So I'm also the founder of the data engineering community. I have an honor. I'm very proud to be the founder of the data engineering community. As Blessing mentioned, it is a vibrant community that keeps growing, and it's amazing what we've been able to do over the years. So outside of this, my professional career and everything, on a personal level, my hobbies are I love to learn. I'm a very inquisitive person. I ask questions a lot. I'm very curious. I want to know why behind almost everything. Sometimes I'm always thinking, so that I rarely find myself in a position where I'm not thinking, and it's very, I don't know if it's the same for everybody here, but I'm always thinking. I always have something going through my head, processing and thinking about something. Other than that, I enjoy playing football. I love football so much. And there could be a possibility that if I have not went the route of academics, there is high potential I might have been like a professional footballer. But it's been a while I've played football, which is very weird. I've not played football like for a few months now. I should get back to playing football. Yeah. So other than that, that's just a brief about me, and I will not bore you with any other details that don't need to know about me for now. So with that in place, we'll move on to this webinar goal. And yeah, you can see a football there as well. But this goal that we're talking about now is not the one scored by Cristiano Ronaldo. So it's just the aim and objective of this webinar. So why are we here? And very simply, I'm someone that is always about why, and you're going to hear a lot of why today. So get used to it, hearing why. And I encourage you as well to always ask why, get to the habit of asking why, because it uncovers a lot of things that, ordinarily will not be surfaced to us as human beings. But by asking that why, it uncovers a lot. So there are things I've kind of observed within the data engineering space, within the community. And one of them is in terms of unstructured data. So I understand even for beginners and a lot of us, we are very conversant in working with structured data, data that fits into rows and columns. We are very conversant in that, any project we do, most likely 99.9% of time, it's usually with structured data. But the interesting thing is data engineering goes beyond just structured data. There are many things to data engineering that goes beyond structured data. In fact, the largest amount of data that we have in the world currently is unstructured data. So I've observed there is a kind of gap in terms of visibility and awareness about what other data types and other things that we have in the data engineering space that is different from the structured data. So, and that's one of the reasons why I felt, okay, fine, vector databases, which is one of those databases that is used to manage unstructured data, could be a potential topic. Now, combining that with something interesting, which is generative AI. Yes, I'm sharing my screen. Delam, are you the only one having that issue? Can anybody confirm they can see my screen? Blessing on anybody, so that I can
see
know.
your screen. You can see your
Brilliant.
screen.
So Delam, it might just be your internet. You might need to log off and log in again. Yeah. Okay, please log off and log in again, and you should be fine. Yeah. So as I was saying, so coupling that with unstructured data with something interesting and something cutting edge, which is generative AI, all about artificial intelligence. And there is also like a lack of awareness in that aspect as well. We are data engineers here, but we shouldn't just be dealing with moving data alone. We should be aware of things that go around us, innovations that comes up, and things that are actually going around us. So I thought it would be a good idea to come up and speak about this and share some insight into all these things that makes up, even a broader data engineering perspective for us. So that's the reason why I actually chose this topic. And as regards my goal for this webinar, so my goal, you can already tell from my why for choosing this topic and wanting to present this to us. You can already pick from the why that one thing I want you to leave here from is to have an understanding of unstructured data and how you can handle unstructured data, and also for you to be able to understand from the point of I don't know what generative AI is or how I can maximize the compatibility or what are the initiatives that can come out of generative AI, to now having like a sample or an idea of what it means to augment generative AI and have an idea and use cases that you can then think of maybe for your personal work or even at your organization, what we can do to implement things that bring about growth and contribute to drive business performance in your organizations. So that will be the goal for this webinar. And I want to trust you that you're going to help us achieve this aim by listening, by contributing, and by following us through the webinar. With that in place, I'll quickly walk us through the agenda. What are the things that we're going to talk through in this webinar today? So the first thing is the why. So we've already seen that, you've noticed I started with why already. There has to be a couple of why that's going to come in place. Again, why is always important. As simple as it is, it's a very important word that you should be conversant with as a data engineer, especially. So we talk about many whys. We move on to generative AI. We're going to demystify generative AI. We go from the stage of I just use it, or I don't know what it is, to now I know what it is, and I know the technology behind generative AI at high level, at least. Unlocking. So we'll be doing a lot of unlocking. We're going to be talking about vector databases, which is a special type of database. And at high level, we're also going to be having like an hands-on demo. So if you really want to build something and you want to get hands-on, at the end of the presentation, we're going to have like an hands-on where I walk you through how to build something that is meaningful and interesting, and also open your eyes to inspire you to start thinking about how you can also do some things. Maybe like you can even start something for yourself and grow to something that is even bigger. So yeah, that was what we're doing today. And this is just high level. There are a lot of details under this agenda, but at the high level, these are the things we're going to be discussing today in the webinar. And as I move through the webinar, as Blessing mentioned, if you have any questions, so you don't forget, you can please drop it on the chat and we just respond to everything. And if at any point in time you stop hearing me or something's not going well, please let me know so that I can react to it. Yeah, without further ado, let's start. So again, another why. So as a data engineer, why should you care about AI? You are a data engineer, it's artificial intelligence. Why should you care as a data engineer? What does AI has to do with you as a data engineer? You need to understand this first, because one thing I've understand and one thing I've always observed and reasoned about is a lot of people have difficulties in understanding something because they don't know why that thing is important to them. You want to learn Python. Why do you want to learn Python? You want to learn about data warehousing. Why do you want to learn about data warehousing? Why should you learn modeling? A lot of these things, without understanding these fundamentals, and a lot of people have seen, from my interaction in the community chat, I'm always asking like why. I want to transfer to data engineering to data engineering. How should I go about it? My first question to you is why? Why do you want to transfer in the first place? Because if that part is missing, there is nothing. The foundation is already collapsed. There is nothing you can build on it that is going to stand. So why should you care about artificial intelligence as a data engineer? And the first thing I will say is, whether we like it or not, whether you agree to it, whether you disagree to it, AI is changing the world. That's the fact. There is not way to say that AI is changing the world, and it's not a new thing. And to be honest, generative AI just brought AI to the spotlight. There's a lot of things that has been going on that is AI. A lot of things. And I was thinking about some of the things we even do as a programmer, knowingly or unknowingly, directly or indirectly. Somehow we create AI applications in our programs. If we create a Python function that does multiplication, for example, so that Python function, we will pass to integer, you pass 2 and 2 to that Python function as an argument, is going to return 4 to you. In a way, that is an artificial intelligence, because the function, if you permit me to say that, the function itself is now intelligent to know that anytime I receive 2 arguments, what I'm going to do about those 2 arguments is I'm going to multiply it together and I'm going to provide an answer. So that, in a way, that function is accepting inputs, is able to make decisions based on that input, and is able to generate output on that input. That's an artificial intelligence. So for generative AI, agentic applications, and all these things are just things that have now bringing it to the limelight, and a lot of people say, oh, AI is changing the world, AI is going to change the job, oh yeah, we are going to lose our job. No. So AI, it's something that is already changing the world, and it continues to change the world. It's going to change how we're going to do things. And data engineers are the heart of it. And that's one thing I'm always lucky for, that I'm a data engineer, and I make that transition to become a data engineer. And I will congratulate you if you are a data engineer, Ada, because you are the center of all these innovations. Nothing exists, I repeat, nothing exists in artificial intelligence, machine learning, or all those cutting edge tools without data, because data itself is the foundation of the whole universe. I keep saying this for time immemorial, like, I've understand data to the extent that I can see data in everything I interact with in the world. Everything. There is nothing you want to tell me that doesn't have an element of data. It's data. The word itself, it's whether you, even though you believe in a religion, if you believe as a Christian, as a Muslim, there is still element of data in everything you do, in your belief, in everything that encompasses the universe. Everything you see is data. You can attribute data to everything. And the interesting thing about that is also that beyond data, I also learned something recently from somebody mentioned it. I want to remember the name of Professor NDBC. If you know Professor NDBC very well, he said something around the world is made of numbers. and we're going to get to that later. The word itself is made of numbers. So, but yeah, so what we are saying is it's important for you as a data engineer, because I'm a little fast. Okay, I'll take it slow. Thank you for that feedback. I mean, I process very fast and I speak very fast, so but I'll take it slowly. So AI is changing the world, no doubt about that. And we data engineers, we are the art of it. So that means you have a rich role to play. And how can you even make changes? How can you contribute to these ever-evolving changes without actually having a perspective, having an understanding of what is at stake and what is all about? And I used to tell people that data engineers, we are like the central nervous system of these things. We influence a lot of things. We overlap with a lot of things, and as a data engineer, I don't want to be a data engineer that just move data, if that makes sense. I want to be a data engineer that is balanced, which is something I call a balanced data engineer. I want to be a data engineer that is able to understand business problem, translate it to solution. I want to be a data engineer that is able to set up proper infrastructure to scale AI analytics or anything that is going to be, the data is going to be used for, build proper pipeline that is efficient, do a lot of things around, manage project properly, and do a lot of things that makes me a balanced data engineer. So this is one of the reasons why I believe you should care about AI, because as a data engineer, you are not just moving data, you are, power intelligent application. Another thing is the role of data engineers is evolving. Yes, evolution is constant, change is constant. If you look at how things have been done in the past and how things have been currently done, the way we are doing things now is not the way that has been done 10, 20 years ago, even 5 years ago, even 2 years ago. Things are changing. And as a data engineer, you need to be conversant, you need to move with the space and understand what is coming, what is changing, and see how well you can suit what is evolving. You simply need to adapt. Yes, like I said, things keep changing. There have been new technology, there have been new advancements, there have been new transformation. So far, we keep learning as human beings, we keep discovering things will continue to change. And as a data engineer, you need to have that skills to adapt. You need to be able to adapt your learnings into all these things that is changing. And I say this, that as a data engineer, you are more than just a builder of pipeline. You are an architect of intelligence. So again, why is this topic important? Why do we need to discuss about vector databases, and why do we need to discuss about generative AI? AI is data hungry and you are the provider. Again, generative AI itself, its foundation is data. And if you want to make the most out of it, you need to feed it fast, accurate, and efficient data. Without that, nothing is going to fail. Nothing is going to work. Even the most efficient model is going to fail. If you understand tools like vector databases, you can directly influence sources of AI applications in your organization. So with this set of knowledge and skills within your toolbelt, you can already start influencing initiatives. A lot of organizations now are moving to explore how they can use all these cutting edge tools and technologies to improve their business. Business is always about how can we reduce costs, how can we make more money. If you as a data engineer, the only thing you do is to bring cost to the business, you are not improving anything, you are not adding anything to the business, no value, trust me, you are better not, the business is better not having you. So as a data engineer, you are a problem solver, and having these skills within your toolbelt means you can be able to influence initiatives, you can bring about things that is going to change your organization and help your organization either increase costs, make more profits, or even just bring value to the business itself. Also, this is going to help us to understand the overlap between artificial intelligence and data engineering. Data engineering rarely function alone. It's that one of those fields that you can't just be alone. You have to work with many things. You're just like an engine in a vehicle. The engine itself, no matter how powerful it is, even if it's V12, V1 million, whatever the V engine that it is, it can't function alone. You have to build an entire body and entire specs and features around it for it to become something valuable and something useful. So data engineering really work. Data engineers really work alone. So you really have to overlap with a lot of roles. And understanding this means you can be able to overlap with AI and work with AI engineers and also influence things in the business and in the organization. So now let's begin. Let's dive right in. Vector databases. So we're going to be discussing vector databases. I know this sounds, the topic might sound cutting edge and advanced, but trust me, it's very basic. And we're going to be breaking it down into something that is going to be as granular as possible and as beginner friendly as possible. And I'm sure by the time you are done, you'll be able to demystify all these things and you'll be able to talk more about this topic. So unlocking generative AI, these are the 3 things we're going to be discussing mainly. So we're going to be talking about vector databases. We're going to be talking how can you unlock them. We're going to be talking about generative AI as a system. So, but I'm going to start from the reverse. So I'll start from generative AI, then I'll go to unlocking, then I'll go to vector databases. So for generative AI, to understand generative AI, I would like us to understand the bigger picture, because again, I believe to understand a piece of something, it's important to understand the whole of that thing. I'll repeat, to understand a piece of something, it's important to understand the whole of that something. If you want to become a data engineer, you don't just start by learning SQL. You start by understanding what a data engineer actually does, what is data engineering, and different things in data engineering, which is why I'm always clamoring and advocating for fundamentals. In anything you want to learn, make sure you understand the bigger picture before you actually dive into the granularity of that system, of that thing. So to understand generative AI, we start by understanding artificial intelligence. What is artificial intelligence? And this is the simple definition I can give artificial intelligence. It refers to the simulation of human intelligence in machines that are designed to think, learn, and make decisions like humans. Forget about the English. What we are trying to do in artificial intelligence is we are trying to mimic human intelligence. Human beings, by default, we are intelligent species, we are intelligent animals. And because we are intelligent, we have been able to discover that we can also create something that is also intelligent. So the whole buzz around artificial intelligence just around making something, making a machine act like human. So either it's learning something, being able to make decision its own, being able to think for its own, and a lot of features that we do as human being, giving it to a machine and making that machine as intelligent as we are. That's what artificial intelligence is all about. And in artificial intelligence, there are different types, there are different subcategories of artificial intelligence. There is robotics, there is machine learning, there is a lot. But for the sake of this webinar, we are going to be going granular, and we are going to be talking about machine learning. So we're speaking the machine learning aspect of artificial intelligence. And to understand machine learning, I came up with this simple definition to say machine learning is the process of training a piece of software called a model. We are going to demonstrate what a model is, to make useful predictions or generate content from data. Simple. Making a machine to learn from data, and from that learning, then able to make prediction, do something useful. What we are actually doing with machine learning is, again, we are trying to mimic the human brain. How does the human brain learn? Human brain, in a way, it's just an algorithm. So an algorithm is just in computing, for example, it's just a set of computations that is able to do things step by step and is able to generate outputs. That's algorithm. That's the same thing with our brain. So when you are born as a human being, you are born with an algorithm, but that algorithm then develops what you call a model, which is then when the brain actually forms. And it's interesting because I have a baby now that is 2 to 3 months old. And the interesting about it is when we gave birth to the son, he is not aware of anything. He couldn't, I remember that you have to play with with my son, and you have to like, hello, how are you? Talk to him. He can't respond. He doesn't even react. He doesn't even see you. I'm not even sure he can see you that you are there. So at some point you have to laugh, keep talking, keep laughing. He doesn't laugh back. He doesn't react back. He's just there, just eat, sleep, eat, sleep, eat, sleep. But what we discover is as time goes on, this person that initially was not able to, even react, or is not even aware that you are there. But because you keep talking, you keep playing, you keep playing, papa, you keep, playing with the child. So recently he has started, responding. So that means now his brain has developed to a stage whereby he has learned something. He can now see people around. He can now see that you are laughing at him, and he's able to laugh back. He's now making effort to also speak back, and that's where they start, doing all those, their own accents and their own languages that they only understand. So what I'm saying now is if you translate that to machine learning, what we're actually doing is we have an algorithm, which is like a brain that can do a set of activities. But that brain itself, you need to feed it with data, you need to train it to be able to make something useful out of it. And that process of actually making that algorithm useful is what we call training. And what we get after training that algorithm is what we call model, which is like a framework now. So now with that model, it now means because that model has learned from data, you can now ask that model something, or you can make that model to do something based on that data, and it's going to give you outputs. Now, because using the analogy of a baby now, because the baby has learned different things, that when you laugh, you are trying to play with him, or you're trying to play with her, he's not able to learn. And from there, he has formed a model. It made us form like a model, and it can respond back to you when you actually want him to laugh at you or to just speak, And that's what machine learning is all about. It's all about mimicking the brain. Okay. Another aspect of machine learning that we need to talk about is deep learning. So deep learning is actually, machine learning is also very vast. So there is this part of supervised machine learning, there is unsupervised machine learning, there is reinforcement learning, there is generative AI. So supervised machine learning, just to talk about it briefly, is when you train a model with input and label. So you tell, just like I have a baby now, you have a baby, or even you as a person, you want to learn something, you usually have to, supervised learning means you learn from examples. I want to believe a large number of us have origin in Nigeria. You remember during WAEC and JAMP, there's usually this common past question, JAMP series, WAEC series. And it's really very useful because what we are trying to do with that is we have series of questions for like 10 years, 20 years of questions that have been solved, and you have answers to those questions. And what that is helping us to do is it's helping us to learn patterns. So you can see questions and see how it's been solved. And by the time you walk through series of questions, you begin to form a pattern whereby if you see a question, you can already tell, oh, this question, this is how it's going to be solved. And that actually improves people's performance during WAEC, during JAM, and even in universities. You always have to like rely on past questions to be able to learn patterns and see, well, how is the question being set and how do I need to approach it. The same thing with professional certification as well. It's the same thing. So what we are actually doing with supervised learning is we are giving machines, say, anytime you see this thing, this is a red color. But anytime you see this one, this is a blue color. So we give the machine different colors to say, for example, red, blue, green, yellow, and with different training method, constantly give large set of data, the machine will then be able to form a pattern to say, anytime I see something that looks like this, it's most likely going to be a yellow. Anytime that looks most likely like this, it's going to be like a green. And when you then input something, maybe an object, you then ask, what's the color of this object? Because the machine learning have learned so much from different data, it's then able to give you like, oh, this is a yellow color. And that's what machine learning is all about. But deep learning is just the aspect of that machine learning that is focused on mimicking the human brain. So it has something we call deep learning, which is layers of neural networks, whereby each layers deal with something. So you give the machine an object. So a layer might be to just identify, the color of that object. Another layer might be to identify the length of that object. Another layer might deal with understanding the content of that object. So deep learning is just like a specialized subset of machine learning that's mimicking the human brain. Finally, we have what we call generative AI. So this is where we are going to be focusing on today. But this is the whole picture, overall picture of how we get to generative AI. And simply put, generative AI works by learning patterns in data and then using those patterns to generate something new, mimicking human creativity. Again, from my analogy of machine learning, you can already tell that generative AI is nothing but a machine learning, what's it called now? A machine learning model where you can feed in a lot of data, and from that data is able to generate new content. The same way you learn, when you want to learn about data engineering, for example, you read so many articles, you watch so many videos, you do so many projects, a lot of documentation reading and a lot. And it gets to a point whereby if you are then being asked what is data engineering, you don't need to check a book, you don't need to go anywhere because you've learned so much things about data engineering and you cannot generate content that is then going to answer what data engineering is. And what we are going to see about data engineering is most likely not to be the same, word for word, with what you read in a documentation or what you read in any article or what you watch in any movie. It's going to be like an original content of you because you've learned to understand what data engineering is. You've recognized the patterns in understanding what data engineering is. Then you are able to develop a new content from that. So what the native want to do is mimic that same process of how human beings are able to be creative from learning from different things and coming up with new content. That's simply what the native AI is. And I have this quote again to say, to understand artificial intelligence is to understand human intelligence. So that means for you to actually understand artificial intelligence, you really need to understand human intelligence. And which is why I've given a lot of scenarios, a lot of analogies about human intelligence so that I can bring it home and I can make us understand what it actually is to understand artificial intelligence. Another deep dive into generative AI, just to make it make sense so that you can understand what you actually mean by generative AI, is imagine if you have an artist who studies thousands of paintings, observing their styles, techniques, and patterns. So later, these artists can, from their own painting, they can create new and original painting from just understanding the different paintings and just seeing how things have been drawn. You cannot draw something that is unique to them, but because they've learned some things. And that's why there is this saying that there is really no new, what's it called now? New content. All content are derived from old content. That's the truth. So, and there are different types of generative models. A lot of people are familiar with the LLMs, which is large language models, which are the one that is usually used to generate output from an input. there are a lot of generative AI models that are going to be talking about, and usually, categorize them by their type of inputs and type of outputs. So it depends on the type of input the generative AI gets and the type of output it responds with. So that will determine what type of model that generative AI model is. We'll be demystifying that in this slide. And the first one we start with is text to text. This one is very common. So this is what ChatGPT, Cloud, Copilot, the version that just prompt and gives you an answer is usually a text to text. That means you give it a text input and you're going to give it a text output. So if you ask what is data engineering, that's a text input. It's going to then respond, data engineering is blah, 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 blah. That is text output. That is a model type of generative AI. It's just a type. There are other types of generative AI, but this is like the common one that everybody are conversant with. The same thing with Meta AI on WhatsApp. If you ask it something, it's going to respond back, text for text. Now, another generative AI model type is text to image. If anybody has played with things like DAL-E before, so these are like text to image. You type text, you can describe something. You can say, give me an image of a man sitting beside an ocean, on a chair, and it's going to take that text input and it's going to use it to create something that resembles what you've described in your text as an image. And that's a type of text to image model. We have what we call text to video. The same thing with text to image. You can also have a model type of generative AI that once given a text input, is going to give like a video output. You can describe something and it's going to create content out of that. An example of this is OpenAI Sora. If I ever, there is a buzz around it I think sometime last year, that it described Lagos in 2030, and that was insane. So yeah, that's another type of generative AI model. There is text to code. You can just write text to a generative AI model, and it's going to code it for you. You can say develop an application that does X, Y, Z, and you're going to take that text out, understand what you want to achieve, and you're going to write code for you. And we also have text to speech. This is where you use things like voice assistance, whereby you type something and the generative AI model is going to translate what you've typed into a speech. It's going to give you a speech output. There are other different types, but we just stop here. We can also combine. So you can combine text to image as an input. So you give a generative AI model text and image, and it gives you a text as an output. So you can combine, but these are just like the foundational generative AI model types. Okay, yeah. So let's demystify some of the concepts we'll be looking at to understand some of the explanation we'll be having going forward. GPT. A lot of us have heard about GPT, but I'm not sure if everybody understands what GPT actually means. So I'm going to be demystifying that. GPT simply means generative pre-trained transformer. That's what it means. And this is the core model behind tools like ChatGPT. So ChatGPT itself is the application, but the model that sits behind ChatGPT is what we call GPT. And it simply means generative, which means it can generate something new. So given an input, it can generate something new. It can generate an output from that input. And the P there means pre-trained. So that means it's been trained, pre-trained. It's been trained with some form of knowledge, and it means it has a cutoff date. So that means GPT model is only able to know up to the cutoff date of that GPT. So for example, if a model is being trained with data and the latest data the model is trained with is January 2025 data, that means if anything happens after January 2025, the model is not aware of what has happened because it's pre-trained. It's been trained with some data and it has a cutoff date. That's what I mean by pre-trained. And the last part of it is what we call a transformer. So transformers is simply an algorithm that is behind the GPT model. So transformer itself is an algorithm. And remember what I said about algorithm, you can diversify them, you can trade them with data and make a model out of them. Depending on the kind of data you feed into it, that will determine the kind of model you get out of it and what the model can perform. So transformer is actually a Google research, and I think it's somewhere around 2017. That's where Google Research released a paper around something they called Attention is All You Need. Attention is All You Need. That's the name of the paper. I'll share after this call. It's a very interesting paper. So, and what they are trying to do with that research is they try to create an algorithm that's given an input, that algorithm can predict the next word. So if you want to say, my name is Najeeb, so the algorithm will be able to tell you to say my name and know that what usually come after my name is usually is. So it's going to predict that the next thing that will come after my name is. So that's what the algorithm is all about. And the paper just define and explain, how they are able to achieve this. And they have something that is very particular about attention mechanism. So that's the key point there, attention mechanism. So the algorithm is able to be aware, understand the context of the input, and from that understanding the context of the input, is able to process it and use it to predict the next word. So that's what transformer is all about, and that's why the GPT is coined from these three important things that make up the generative AI model for OpenAI ChatGPT. And lastly, we can talk about LLMs. So we've talked about, LLMs are everywhere nowadays, but they are simply large language models. So that means GPT itself is an LLM because it's been trained with large language, which means huge amount of data sets. And now it's become a model, and now you can be able to get inputs. And by giving input, you can be able to generate outputs. That's what LLM is all about. And there are different LLMs. So there is ChatGPT, which is GPT that relies on GPT. There is Gemini, for which you want from Google. There is Cloud, I've forgotten what it's called now. So there are a lot of them that, all based on this research from Google, which is Transformer. So that's the core algorithm behind generative AI. So by understanding these things, you can now start to picture how some of these things work together. So when you type into ChatGPT and you say, ChatGPT, what is data engineering? Or ChatGPT, explain to me like I'm 5. Cloud AI, thank you. Explain to me like I'm 5 what data engineering is. So what we're essentially doing is, I'll tell you how it works. So this is how it works. The ChatGPT itself, the interface, is just a web interface that makes API call to the model. Remember, model are pre-trained. So that means you can have them like, the output of model is usually like a binary. So that means you can then interact with that model the way you interact with a server. You can send an API request and it's going to respond back with something. So when you type something on ChatGPT, what you're simply doing is you are making an API call to the model, which is GPT, behind ChatGPT, and the model will translate what you've typed into context, what's something we call embeddings. Using that context, it's able to then predict what should be the answer because it has learned so much from a lot of data, from articles, from blogs and stuff like that, and is able to then respond to you back with what should be like the right answer. So which is why some people said ChatGPT is not all you need. And that's the truth, because if you don't understand it, that's when you use it wrongly. That's when you expect that ChatGPT should be the thing to solve your problem. Things that you're supposed to check in documentation, you leave documentation, you go and check ChatGPT because you don't know what ChatGPT is capable of and what it's not capable of. In fact, if there's anything, like I said, if there's anything that is beyond the context of the training data of ChatGPT, ChatGPT is not aware of it. So that means if you're using ChatGPT to do some things that are not feasible, you get a very inaccurate answer, which means you then blame ChatGPT that ChatGPT is not this, is not that. But what they're actually meant to do is just to augment. They are not meant to replace some of these things we do. So, but they are meant to support these things we do. You are still expected to check documentation. You are expected to read. You are expected to try and solve problem yourself, not relying on ChatGPT or Cloud AI or all these other LLMs. So that being said, because of time, I'll move quickly so that we can cover as much as possible. The next thing we're going to be talking about is unlocking. So if generative AI has so much potential and they are very great, why do we then need to unlock them? I mean, we already know about cool things we can do with generative AI. You can just type something and you get a response. You can use it to solve problems. You can use it to get explanations. You can use it to generate content. They are so good. They are so great. They have limitations, yes, but why do we need to unlock them? And that's where we need to explore their limitations so that you can understand why. Why do we really need to unlock generative AI? Because they are not the answer to all the problems. And the first thing is, models are not good at memorization or recall of specific data. I will repeat, models are not good at memorization or recall of specific data. Like I said, ChatGPT, Cloud AI, or all the generative AI models, the common ones, Meta AI, they lack memorization. They lack retrieving specific data. And you believe that when you ask ChatGPT about something, it's not giving you, it's not like some people might believe maybe those LLMs are storing the data somewhere. No, they are only trained to recognize pattern in data. So when you ask ChatGPT, what is data engineering? ChatGPT is not going to a database, to pick, oh, I have the definition of data engineering stored somewhere, then I'll go and retrieve it, then I'll not give it to you. That is the definition of data engineering. No, the way it works is it's learn patterns. So there's something called parametric knowledge. So they are the things they learn during training. So you feed it what's data engineering, the different aspects of data engineering, and all other things. And because ChatGPT has been able to learn from those data, the only thing that they have now is pattern. So they've learned pattern from that data. They now have what we call parametric knowledge, which is not an actual knowledge, not a source knowledge. So that means any content that is generated by all these LLMs, they are not factual contents. It's not like they're going to documentation and pick it verbatim. Most times they are picking, yes, they've been trained with all this documentation as well, but it's not like they have to go to like a database, pick the exact data, the way it's written, and give it back to you. And which is why they are able to, predict and generate even new content that is not even on, documentation or anywhere. So they are not good with memorization. They don't memorize and they don't record specific data. So if you train ChatGPT on, say, factual data now, maybe your organization data, it's not going to remember when you ask it the fact data most times. And I'll give an analogy. As a person, and I believe our brain also works similar to this. As a person, if you are preparing for an exam, right, and you read a book, let's say 2 weeks in advance, you've read all the material, the course materials, you've read everything that you need to read about the course. And on the day of the exam, you now try to answer some questions. Trust me, there is possibility that you are not going to remember everything word for word because it's been a while that I've learned. That's one. And at the same time, except you memorize, what you have just learned is you learn patterns to have an understanding of the course material so that when asked questions, you can be able to develop your own idea, add your own creativity to it, and answer the questions the way you understand it. That's how LLMs work as well. But we need to do something even more for us to be able to achieve when you want to retrieve factual data. You understand what I mean now? So when you want to achieve factual data, that means LLMs is not enough, and this is a limitation. And I have something just as an example here that if you ask ChatGPT about a recent event, so after its knowledge cut off, he's not aware. I've said it before. He's not aware of what has happened after it's cut off. Nothing is going to be returned. And if you want specific factual domain specific response, you need a system to store and retrieve that data explicitly. And that's where you need vector database. So secondly, models cannot handle dynamic or real-time updates. You can't keep training model every time. So let's say, for example, you've trained GPT, which is the model behind ChatGPT, has been trained with billions and billions parameters of data. And the cutoff date is January. So by February, it's very difficult for you to now say, because now there are new data sets, I'll now train the model again in February. Then in March, we continue to do the same thing. So generative AI, they lack this. They cannot handle dynamic and real-time update because they are not flexible enough to be able to update their data sets and learn from new data as frequently as human was in it. So that means it's a limitation. And we usually require like dynamic knowledge, real-time updates into our response when you want to interact with all these LLMs. And we can solve this problem by vector database as well. Another important thing to note is scalability for large language model and for knowledge base rather. Because it usually requires huge amount of data, that means it's difficult for you to build scalability into GPT models. It means you need to have like an external systems whereby it's scalable and you can refresh, you can upscale as much as you want when you want to maximize the potential of generative AI. Another important thing I didn't add to this slide is hallucination. Generative AI hallucinates a lot. Most times, generative AI will always give you an answer. Most times, 90% of the time, even if it doesn't know, or even what it's saying is not correct, you always find like something that relates to something and always respond to you. And that's what we call hallucination. So that's a limitation of generative AI. And we can unlock all this limitation by augmenting it with something and build an ecosystem around this generative AI. And that's why we'll be talking about vector databases. Okay, before we talk about vector databases, I would like us to understand again why vector databases. I mean, there are a lot of databases. Yeah, I'll share documentation definitely. So there's a lot of database already. There is relational database, there is NoSQL database. A lot of databases exist. So why do we need vector database? And I would like to mention that vector database is not a new technology. It has been around for a long time. The only thing is generative AI has brought it to the limelight and is making it now get a lot of attention. And which is why a lot of companies that have vector database as their products, they are now cashing out big time because it's not like go-to tools for GenAI applications and unstructured data to some extent. So, but why do we need to use the vector database? And I said is that to really understand why we need vector database, we need to effectively explain why. Sorry, we need to align the challenges with traditional systems in handling modern AI-related tasks. If we already have some databases, we have MySQL. Why my mic was muted? Can everybody hear me now? Blessing, can you hear me? Okay, good.
Yes, I can hear you.
Okay, thank you. So why do we then need vector databases? Because all these things are already, we already have database existing. So which is where we're going to talk about the strengths. So what is the strength of traditional databases? So traditional databases are databases I called scalar databases. For some of us that maybe not have like a science background, I will explain. So scalar databases are like all these relational database, MySQL, SQL Server, and the likes. Their strength is to store structured data, and they are very good and excellent in storing and retrieving precise and structured data. So that means if you store that customer name Najeeb, is good at storing that exact record, and it's good at retrieving when you want to query. Now say where customer name equals to Najeeb. So they are very good with exact search, and they're very good with storing structured and semi-structured data effectively. But what are the limitations? They solve a lot of problems that we actually currently have in the world. We use them for transactional processes and a lot of data storage and processing and the likes. But they have limitations. So by understanding the limitations, we're then going to understand why we need to bring vector databases into the discussion and demystify what vector database actually is. So that by the time we then demystify what vector database is, it's become clearer why we are doing it and what is actually vector databases. So one of the limitations is that in the era of AI, I've said this before at the beginning of the presentation, that over 80% of data is actually unstructured. And it's interesting because it keeps growing as data becomes accessible, generate even more data. That means we continue to have even more unstructured data than structured data. Structured data are data for those of us that, I'll try and break it down. Just data that are not structured, that you cannot fit into a row and column. So it could be text. So things like your WhatsApp chats is not a structured data. Your Twitter, X tweets, your LinkedIn messages, your posts is not a structured data. Images. So the images we have on the internet, they are unstructured data. Videos, all those videos you watch on YouTube, they are unstructured data, and so on and so forth. And if you look at it critically, those are the kind of data that makes the huge percentage of the data we have available in the world. And the era of AI is even becoming more vast, because now we can generate even more content. So, and all these traditional databases, they struggle when we come to maximizing the potential of all this unstructured data, because this way we are going to process structured data is different from the way we are going to process unstructured data. Unstructured data usually require a lot of mechanism, a lot of processes for you to actually make meaning out of them. Because trust me, they are chaos. Raw data, raw unstructured data, they are chaos. You usually have to apply different techniques to make meaning out of it. Unlike structured data, whereby you can already see different properties and different attributes of a data, and you can already tell what it means. So, and traditional databases struggle with similarity search. So this is one feature that is very important in the age of AI and in the aspect of unstructured data. Similarity search simply means unexact match. That means if I'm looking for something in a database, even if I can't get the exact thing, I want to get something similar. And I'll give you an example. If you have a database and a relational database, you store something like fruits, you have a product in your business, you have fruits, clothing, electronics, and so on and so forth. And a customer comes to your website and is looking for, let's say, mango, or he's looking for orange. Now, the way a traditional database will do it is going to find where fruit's name is mango, or like mango, or something like that. Let's just use that as an example. But in the era of unstructured data, you can even search with images. You don't even need to mention mango. By selecting an image of mango, we can have a system that is going to translate that image into just data, and it's going to use it to filter our database to check, is there anything similar to mango? And it's able to then bring it to, okay, fine, we don't have mango, but we have orange, or we have apple. And this is the same thing that is used on Netflix, on Spotify, on all these YouTube, and all these applications that we use. Usually when you want to check for something on Netflix, maybe you want to search for a movie. When you search for that movie, you usually don't get only that movie. You get movies similar to that movie. And it's not usually because of the title. So if you are looking for something like Squid Game, so you will see that you get something related to Squid Game, even though the title is not the same as Squid Game. So, and that's what we call similarity search. It's going to process the data of that video, understand the context of that video, and it's going to go into the storage and check for similar things on that data and use it to, predict something for you. That maybe you may like this or you may not like this, or tell you that, oh, we don't have Squid Game, but we have something similar. So these are the way we use, structured data and process them to make money out of them and use it to drive organizational growth. Another thing is high-dimensional data. Usually, when you look at relational database, for example, everything stored in a relational database is an entity. And the columns now, they are like the attributes that used to store that entity. If you have a product, for example, or you have a customer, I'll use this as an example. You have a customer. A customer in the database or in a table is an entity, but there's different attributes that define that customer so that you can know that this customer A is actually different from customer B. So in that way, you use things like the name of that customer, the age of that customer, the gender of that customer, the location of that customer, and so on and so forth to uniquely identify that customer. But when you come to high-dimensional data, dimension simply means properties. It means attributes. It's very difficult for you to have a table in a relational database that is going to have like, just 1 second, I need to move this person. Okay. Yeah, that is going to have like 1,000 dimensions, which means 1,000 attributes. When you have that scale of table that's having 1,000 attributes, you become inefficient. So, and that's where vector database actually shine. They shine with dealing with high-dimensional data. That means you can now encode and decode your data and translate it to high-dimensional space. More on this later. So as we move on, you're going to understand more on these dimensions and everything later. And another reason why we need vector database is simply because generative AI models, they need context. When you search something with LLMs, it's not really looking at the text. An example of this is also when you go to Google. And the interesting thing is a lot of people almost all of us, we've been using generative AI even before all this ChatGPT and these likes, but maybe we are not just aware. A simple example of generative AI is also this auto-completion that we have on our smartphones. So if anybody here is using smartphone, there's a high chance that you're already using generative AI, because you know that when you want to type something, before you even type finish, your keyboard is already suggesting what might be the next thing that you want to type. SB, please mute your mic. So your keyboard might already be suggesting what's the next thing you're going to type, and it's going to predict for you what's the next thing. So that's an example of generative AI. And the only way it's able to predict what's the next because it understands the context of what you're trying to type. So the way you are going to it's going to translate is just not what you are typing. It's not the lexical word, but the context of what you are typing. That's what will determine what is going to predict next. The same thing when you do Google search. A lot of us use Google almost every day. And when you do Google search, if you search for example, employees in Apple. If you search for employees in Apple, how is Google able to know that what you actually want to see is actually Apple, a company, not Apple, the fruit? And you see that the law of content that's going to come under employees in Apple is going to be something related to Apple as a company. And you rarely see something that is going to be Apple as a fruit. The same thing when you type sweetness of Apple. When you say sweetness of Apple in Google, it's going to then bring things like Apple to you, Apple as a fruit, and you don't see things like Apple as a company. So that's how generative AI works, and that's the one reason why we need vector databases, because beyond the lexical words, we need something that can give context into what we are doing, and using that context, we can use it to generate content. So that's one of the reasons why we need vector databases, because generative AI simply needs context. Now, another important thing is nearest neighbor search algorithm. So this is the power behind vector databases. This is how they're able to search millions and billions of records of data. They use what we call nearest neighbor search algorithm. And what this algorithm is doing is only checking what is near to what we are searching. It doesn't care for the exact. It just wants to rank what we have in your database and give you what is close to what we are searching. We're going to discuss more on this later, but that's one of the reasons why you need vector databases. So now we need to talk about vector database itself. We've talked about generative AI. I've explained artificial intelligence and break it down to the point of generative AI. Give several examples, different analogies, so that we can understand how these things actually work together. We've talked about unlocking. We've demonstrated why we need to unlock generative AI, even though they have a lot of potentials. Why do we need to unlock them? So I've given you the limitations and everything that makes us want to unlock the power of generative AI. We've also discussed things around vector databases. So we discussed the limitations that traditional databases have and why we actually need vector databases. So with this prerequisite understanding, I believe it's now a good time for us to now dive into vector databases and actually break it down and understand what it actually means for databases. How is it different from traditional databases, and how can you work with them, and how can you maximize their potential? So I'm going to be focusing on vector databases. I'm not going to explain databases as a concept because, I mean, to a large extent, you should you should not be familiar with databases. Yeah, but database is just, I will say again, for some of you that doesn't know, database is not a tool. Please, if anybody is telling you that database is a tool, that person doesn't know what's, I mean, I'll skip that. Database is a concept, data warehouse is a concept, data lake is a concept. They are not tools. A lot of people mix this up a lot. And this is why I always say, know your fundamentals so that you can understand all these things and it becomes easier for you to actually learn and understand something. Don't just learn on the surface. Go deep and understand things to the deeper level. And a database can be a database can be a physical copy. It doesn't have to be something you put on a machine. You know, if you have been around mothers that that have all these retail shops, they usually have like a book where they write, debtors, people owing them money. Some of them have like a ledger where they input things like, oh, how much we sell today, how much is our profit, how much is our cost price. So that thing is actually a database, even though it's a book, it's a database because it's a concept. But when you then talk about tools, let's just talk about things like PostgreSQL, MySQL, and all those things that actually helps you implement database. A database is simply a storage of information in a structured format. That's what a database is. Data warehouse as well is actually a concept, it's not a tool. You can have a data warehouse on MySQL, which is an OLTP database, although not the best practice. But once you implement it on OLTP database, it's also a data warehouse because a data warehouse is a concept. It simply means a collection of data, usually from different sources and historical for the purpose of consumption, whether it's analytics, it's machine learning, or whatever consumption it is. That's what a data warehouse is. Now, the tool you use to implement it can vary. So you can decide to use OLTP, you can decide to use OLAP, but the best part is to use OLAP for data warehouse because they're always performance for analysis query. And by understanding all these concepts, I mean, you can understand what a database is. So I just want to demystify this so that we know that, I mean, databases and all those things, you need to go deep and not just the surface. And with that in mind, you can then understand what vector databases are. To understand vector databases, there's two things I'm sure you need to know. These are the two fundamental things you need to know to understand vector databases. The first thing is vector. You need to understand what vector is. The second thing is embeddings. You need to understand what is embeddings. By understanding two things, it becomes very easy for you to understand what vector database is. But if you don't understand these two things, trust me, it's very difficult or it's almost impossible for you to understand what vector databases are. So I'm going to demystify what a vector is. Then we go to embeddings, then we round it up with vector databases, right? Now, what is a vector? Without looking at these definitions, this is just there for you to be able to picture it and understand it at a deeper level. But I just want to tell you that vector is purely a mathematical construct, nothing else. And usually for some of us that have done a lot of mathematics and also did physics in secondary school and some of us in higher institution, we understand that vector is anything that has both magnitude and direction. Those are the two attributes of a vector. A vector must have, for something to be a vector, it must have magnitude and direction. Sorry, I'm going to be teaching you some mathematics, but it's important for you to understand, not just the surface level, but at a deeper level, so that when you explore further, it becomes very easy for you to interact with these technologies. And the magnitude is usually like the size, how big it is, and the direction is usually like where is the position in space. More on that is going to come later. So I'm going to show you this. So usually somebody said you can't hear me. Is that general or is it only peculiar to this person?
We can hear you.
Okay, excuse me, I'll just drink water. All right, so usually these are represent vector in mathematics. So usually like V, and then there's like an arrow to show the direction. So I can see like this arrow now, that's like the direction pointing to whatever direction is pointing to. Maybe this northeast now, or northwest, whatever, northeast. Now I've forgotten coordinates. So, but skip that. So yeah, this is just telling us the direction of that vector, and the length is the magnitude. The direction it's facing now is direction. So this is simply a vector mathematically, and this is how we denote a vector. Okay. And if you understand that as a vector, we can also then have something that we call dimension, because we said a vector is that has magnitude and also has direction. So that means we can have different dimensions in space. And this is a 4-dimensional vector. You can see like these are different 4 dimensions. So you have north, south, west, and east. So with this now, this is a 4-dimensional vector, and we can have objects all across these dimensions, which represent their position and their magnitude in space. And you can see A, B, C. These are on the same, not the same direction, but they are closer to each other because they've lied on almost the same coordinates. And A is close to B than B is close to C. D is not close to any of them, but is another coordinate. Now, it's better to understand this thing so that we can understand embeddings. Again, mathematically, you can say a vector is represented as an ordered set of number. So if you have ever worked with lists before in Python, that's a vector. In a way, is the same thing as vector, because a vector is simply a list of float numbers. So this is an example of a vector. So when you have a floating number like this, so this is like 0, -2, 3, up to like the n number of objects you can have in that list. So a list in Python can attribute it, can picture it as a vector, because now you can see that this 0 now is the magnitude, -2 is also the magnitude, but minus is saying that it's negative, which is another direction. So that's an example of a vector. And all these things can be used to represent data. And I will tell you why we need to represent data. Now, you all know that computer only understand just one language. Computers, just one language. And the language they understand is 0 and 1. Computer doesn't know anything aside from 0 and 1. That's the only thing computer understands, 0 and 1. Now, it then means that for us to run the different applications we have on our computer, there's a way that we must find a way to represent those things as 0 and 1. So if I type A on my keyboard, I must be able to translate that A into binary for my computer to know that I'm actually pressing A. If I want to design a picture on Canva or anywhere, or just a picture generally, if I want to display a picture, on my computer, there must be a way for my computer to be able to translate that picture, which is now a form of data, into 0 and 1, which is binary. So now, if computer only understand binary and we can run applications, we can do a lot of things on computer that only understand 0 and 1. So that means what we are essentially doing is we are transforming those data, because everything is data, we are transforming it back to 0 and 1 so that computer can then understand what's 0 and 1, what we are trying to do. Now, taking that analogy back to vectors, because data, image itself is chaos. You can't really analyze an image until you convert it to something that is meaningful to the computer, or to this programming, or to the algorithm, or whatever that you're going to use to process it. So you need to transform that unstructured data into something that is more structured for you to be able to make money out of it. And when you look at picture itself is combination of pixels. And pixels are nothing but data. So you have a picture, like you have, okay, fine, even let's do video for an example. So this video is a combination of data, and video are nothing but frame of pictures. So the way you're looking at me now, you're looking at different frames. So if I move my hand like this, that's a frame. So different frames combined together makes a video. And when you analyze a frame, it's combined of pixel, and pixel can also be translated to mathematics so that we can then process it in computer, if that makes sense. So what we are actually doing is we have unstructured data, but we are trying to find a way to make meaning out of that unstructured data so that when you want to process it, it becomes something useful that we can then use to do some other applications. So, and there are different dimensions of vectors, and vectors are usually in higher dimension, but the major one, or I think the maximum we can understand or comprehend physically as human being is 3 dimension. Anything above 3 dimension, we can't comprehend. So, and this is a 3-dimensional vector. So this is 0, -2, 3. So this is like 3 components. So that is the dimension. So the component in a vector is equivalent to the dimension. So when I say 3-dimensional vector, so I'm only saying a vector or a list of 3 objects. That's 3-dimensional vector. If I say 10-dimensional vector, I'm only saying a vector that comprises of 10 objects, which is 10-dimensional vector. That's simply what the vector is. Now, because now it is mathematics, so that means we can, and know mathematics, we can perform different operations. So that means we can now add 2 vectors together because it's mathematics. And we are going to have something like this. U plus V is going to give you like U1 plus V1, comma, V2 plus V2. And also it means we can perform subtraction on it. It also means that we can perform product, we can multiply it. And that's going to give us like different outputs because it's mathematics. Understanding this means if you are able to represent data in this mathematical representation, that means you can then process that data in different formats. That means you can now add 2 data together, you can subtract them, you can multiply them, you can do different things with them because you basically translate it from a chaos form into something that is now able to process by the computer. And I'll give an analogy using Musili. Is Musili on the call? So that I can be sure if just 1 second. Let me just confirm if Musili is on the call. If she managed to join. Musili is not on the call. Okay, that's fine. Yeah, so as an analogy, just to understand vector properly, is let's assume Musili is currently in a house, but Musili wants to visit, just 1 second, but Musili wants to visit Wasiu, which is our baby. So Musili wants to visit Wasiu, our baby, but for Musili to get to Wasiu's house, Musili needs 2 things, right? Musili needs to know the location of Wasiu house, and Musili needs to know how to get to Wasiu's house. Now, for Musili to know the location of Wasiu, the first thing Musili needs to know is, what is my reference point, where I am currently. If you don't know where you are, you can't know where you are going. And when you get to where you're going, you don't even know where you have got to where you're going. So the first place to start is, where am I, which is the reference point. So let's say the reference point here is 0, 0. That is 2-dimensional vector. For Musili to get to Wasiu's house, Musili then predict that, okay, fine, if I go -2, if I go 2 miles to the south, which is negative in the vector, in the dimension, if I go 2 miles to the south and I go 8 miles to the east, so that means I can then get to Wasiu's house. This form a coordinate, which is -2, 8. So what we have here now is a vector, and this is the simple way Google Maps works. If you have ever used Google Maps, the foundation of Google Maps is vector, and what they are doing is just longitude and latitude. So I'm from point A, I want to go to point B. So I need to know where I'm starting from, which is my reference point. Then to get to where I'm starting from, I need to define a vector. So that means I need to go 2 miles to the south and 8 miles to the east. Then I'm going to get to Wasiu's house. That's a basic analogy for a vector. And how do they now relate to machine learning? Embedding is simply a vector applicable to machine learning. So when you apply vectors to machine learning, that's what we call embedding. More on that now. So I say embedding refers to a numerical representation of data, typically in the form of a vector. Remember, you cannot just process video the way you process your rows and columns in relational database. You need to convert them to something that is more structured to process them. And the way you do this is you can leverage vector, which is a representation of data mathematically. And embedding is simply just data. That's what embedding is. Embeddings are vectors that represent data. It's nothing more than that at the basic level. So, but what is important about embedding is that because they are vectors, you are now able to capture the semantic meaning or relationship in the data, and they provide a way for it to be understandable to a machine learning model. And I'm going to explain to you how embedding is able to achieve this using vector. So if you want to represent a text, an image, or other complex data type, you need to have the dimension, so which is at the attributes. So you need to be able to define what is the color of that image, what are the different attributes there, the length, what is the content, and all those things. And from there, you can generate like a vector, which is a list. And each object in the list represents a dimension, which is the characteristics of that object you're trying to define. So an example is this apple. So you want to define apple, like you want to represent apple as a word in a vector database. This is just an example, it's not the correct vector mapping. So it means you can represent that 0.5. You can say 0.5 represents the color. You can say 0.7 represents something else in the attributes. But you can now represent apple. Normally, if you want to process apple, you have to lexically look for apple. But because you can represent it mathematically now, it means you can now perform mathematical operation on apple and use it to derive several other contents. The same thing with orange. So orange means you can now have orange and you can represent it dynamically. Another common example for vector is, because in mathematics, now you can now minus and plus. So if you have a word king and you minus man and you plus woman, that is going to give you coin. So if you have a vector of king, you all know king is a title. But if you remove man, that means that king is not a man. And you add woman, that means that king is a woman. Or whatever. So you can say it's a regent, or you can also say it's a queen, because the wife of a king is a queen. So that's simply how embedding works. You can now do mathematical operations on data that makes sense. Another analogy is this vehicle. So this vehicle, now if you look at it, you can already see some attributes from this vehicle. The color is green, so that means you can represent this as a vector. You can say this one represents the height. So how tall is this vehicle? You can say this one represents the color. What's the color of this vehicle, which is green? You can see this one represents the length. So what is the length of this vehicle? And so on and so forth. So you can have a vector that is 1,000 dimensions. So each dimension represents attributes of that unstructured data you are trying to convert to something meaningful. Okay. Now, another important thing to know is this is a two-dimensional vector space. So which is just not what's it called now? X and Y axis in mathematics, the way you usually say it. And you can see that we have some words that are close to each other. So how close to each other in the vector space determines how similar they are. So if you look at this one now, man and boy, they are close to each other because an adult boy is a man. The same thing with tea, milk, and coffee. They are close to each other because they actually work together. The same thing with dog and puppy. And you can see that data is different from them. So that's how you kind of map similarity between vectors, because now you can see how different vectors relate to each other. So the closer they are in vector space, the more similar they are. And when you are searching for something, that's how you get to find what is similar to the other. So I have something here, but because of time, I will not be able to go through it. So it's a visualization of a vector space, how things are being mapped in vector space. And it's just a Google TensorFlow map. I can share it after this call, but I'll just go over it because of time. So this is the vector embedding workflow. Usually it starts from the raw data. You have your raw data, your text, your images, your video. And once you have that raw data, the next thing you need to do is you need to generate vector out of that data. You need to convert that data into vectors. And the way you usually do that is you pass that raw data into an embedding model. So the embedding model is usually a model that has been pre-trained to be able to generate vectors out of data. So getting an input, the output of the embedding model is going to be like a vector. So and once the vector has been generated, you have what you call vector embeddings. So that's how vector embeddings works. So you have the raw data, it could be text or images, you send it into an embedding model. Embedding model is already trained to be able to understand and translate that data into vectors. And the output of that embedding model is going to be vector embeddings. Now, once you get the vector embeddings out, you can now understand what a vector database is. And a vector database is simply a database that is used to store vector embeddings. That's as simple as that. A vector database is a database that is used to store vector embeddings. Remember, you've converted those unstructured data into vectors. Now, you need to store that vector into a specialized database. Remember, you cannot store it in traditional database because they will not be able to understand context. You can store it there, but it's not efficient. It's not designed to store vectors. So you need to have a specialized database, which is why we need a vector database. So a vector database is simply a database that is used to store vector embeddings. Now, with that understanding, we can go through a vector embeddings workflow. Vector database workflow. How does vector database works? How does it map things together? So, and the first thing is, again, starting from the raw data, you give it to an embedding model, building on the previous slide. The embedding model generates what we call vector embeddings. The vector embeddings is then stored into a vector database. So this is the first flow of the vector database workflow, which is the creation part. From raw data, we generate embedding, we store the vector embeddings, then we store it in a vector database. Now that we have vector stored, so how do we then get data out of this vector store? So that's when we then you can have like an application, or you can have like a program that is then going to then send a query. So that query that has been sent, remember on our database, we already have data stored. The same way you have the select statement to get output from a database, you can have an application that send a query, maybe ask a question. And the embedding model, again, is going to get that query, convert it into something that is called vector embeddings. And because now vector embedding is a mathematics representation, vector embedding is then going to be, the vector database is going to use that vector embeddings to then search the vector database and gives you what is most relevant to your query. It's as simple as that. Somebody's mic is off. I'm just going to mute that person. So it's as simple as that. Excuse me, I'm going to drink water. So that's how vector database works. The first flow is you store the data, convert raw data into embedding, store in vector database. And once you have it in database, you can then begin to perform similarity search on that data and getting output from that data. Okay. Moving forward, this is a part where you get your query result from the vector database. Let's quickly run through how vector databases work. So the first thing you need to know is they're usually vectors, which is the converted data type, list of dimensional data, and vectors are then being passed to indexing. So this is what we call indexing. So one of the core features of a vector database is what we call indexing, because this is actually how vector databases are able to perform fast and accurate similarity search on your data that is stored in the database. Is through indexing, and they have a lot of algorithms that they use to implement this vector search. So it goes to the indexing. This is how the database is able to check the data and compare which is the most accurate accurate index algorithm to use to store this data, so that when you want to retrieve it, it becomes efficient for you to get this data back out of the indexing. And from there, it's going to send it to the vector database. So because now it's been indexed, so that means related vector embeddings are now grouped together and they are now indexed together. So it becomes easier for you to search for them later. And from the vector database, you can now query the database. You can now ask the database question, and it's going to give you what we call post-processing. So when you ask the vector database question, it's going to check the index. So you can look at index as a table now in a database. So you're going to check and look for something that is similar, pre-process it, and give you output based on what is similar to what you have asked for. That's simply how a vector database works at a very high level. Like I said, there are different indexing algorithms. So we have what we called, I'm going to run through them, but to just understand indexing algorithm, they are just techniques to organize embeddings. So we use them to speed up searches. So, and there are different ones. I'm not going to go into details. I'll just mention them. You can read more on them. So we have something we call hierarchical navigable small world. This is my favorite anyways. So, and this use like nodes and trees to be able to do searches on your data, to be able to give you fast queries and give you something relevant to your query. We have what we call FAIS, which is Facebook AI Similarity Search. This one was developed by Facebook and it has its own indexes. Don't even need to use a database for this one. We have what we call Annoy. This one is very interesting as well. This one is from Spotify. It's called Approximate Nearest Neighbor. Oh yeah. So I don't know what you're thinking when they name this thing in Spotify. And we have what we call local sensitivity hashing, LSH. We have what we call product quantization. So these are all indexing algorithms that vector databases employ. And behind this, all these algorithms implement some rules, enable some algorithms and some rules, enable to efficiently store your data, so that when you want to retrieve it, it's very fast and accurate for you to retrieve. Because vectors, like I said, can be thousands of dimensions and they can be millions, and big data. Structured data is unstructured data. They're always very, very big. So, but this indexing algorithm helps us to efficiently store them and get results. Another feature of vector database that we should talk about quickly is what we call similarity measures. So remember, indexing helps you to store your data efficiently, but similarity measure is how vector database handles your query. So when you submit a query to a vector database, you usually maybe through an API, and you want to get something out of the vector database. For you to efficiently get, for the database to be able to efficiently get your query and give you something that is relevant, it uses a lot of similarity search algorithm as well. And we're going to be talking about some of them. So one of them is cosine similarity. Cosine similarity measures the angle between two vectors. So if you have two vectors, A and B, in a vector space, you remember the X and Y axis that we have in the previous slide. So cosine similarity is looking for the angles between two vectors. So the angle determines how close two vectors are. So that means if orange and mango are close to each other, and I'm looking for mango, and I'm submitting a query to a vector database, it's going to return orange for me as part of the similarity search, because orange is close to mango. Likewise, if I'm looking for something else, maybe I'm looking for a man, it's going to return a man and a boy for me, because a boy is close to a man in a vector space. So that's what cosine similarity does based on using angle. Remember, the data is now mathematics representation, so we can perform different mathematics operation on them. We have what we call Euclidean distance. So this one, instead of using angle, this one uses distance between two things. So how far apart two vectors are in a vector space determines how dissimilar they are, and how close they are in terms of distance determines how close they are in terms of similarity in space. Then what we have products, dot products. So this one is really just a combination of the two. So it combines both the cosine similarity, which in terms of looking at the angle, and also looking at the distance between two vectors to give us what is similar in a vector database. I'm very conscious of time, so yeah, we are getting to the end of this presentation. Then we have like a quick demo where we build something, and there'll be room for question. So we have different vector databases. I'll just go over them quickly. We can do more research on this one, and I have a documentation that I will share after this course so that you can look at it. So we have PyCon. PyCon is one of the most popular vector database now. We have Mivoids, we have Chroma, we have Weaviate, Elasticsearch, Qdrant, we have Redis. Redis has a vector search. We have TXT AI. This one is specifically designed for generative AI. We have PG Vector. So this Progress. PG Vector is an extension of Progress SQL. It also has a vector capability. We have what we call Vespa, and all these are like example of vector databases. We have more than this, but these are like an example of vector databases. In terms of whether they are closed source or open source, closed source means you can't have access to this backend code. It's licensed. It's not free, completely free to use. While open source means you can have access to the source. The source code is open. If that makes sense, that means you can contribute to it. You can do a lot of things because it's open. So Pinecone, Elasticsearch, Redis, all these ones are closed. So that means they are proprietary softwares. While all these other ones, PG Vector, Weaviate, Quadrant, Miiverse, so all these ones are open, which means they are free to use. They are not proprietary, and we can actually see their source code. In terms of managed or managed, so I also categorize them. So all these ones are managed. So that means you need to like set up the infrastructure yourself, while all these ones are managed. So with this one, you can already just start working with vector databases, which actually provisioning your own infrastructure. So in terms of built-in embeddings, so some of them actually have built-in embeddings. So which means you don't need to have like an external model to convert the data into embeddings. You can just submit the data and it's going to convert it to vectors for you and store it in the database. So all these ones have no built-in. So that means you have to convert your data to vector embeddings before you can store them into the vector database. While all these ones have built-in embeddings, that means you don't need an external model to convert them to embeddings. You can just submit your query and you're going to convert it to embeddings for you. Okay. Yeah, that's for the vector database. The last part, which is RAG and LangChain. Excuse me. To be honest, I have a lot to cover, but I've selected some of these things and it's even taking time already because it's very deep and I just want you to understand as much as I can. So we have RAG and LangChain. So RAG is simply an architecture. Again, some people see RAG as something else, but to me, it's just like an architectural approach. So it's a way of building AI application by augmenting the retrieval that you get from an LLM with something that you generate. So and it's a way to improve what an LLM generates by grounding it in data that is relevant and not to be accurate. Again, if you want to use an LLM in your organization, ChatGPT, Cloud AI, Copilot, Meta AI do not have any awareness of how much you are selling your products. Does not have any awareness of what is the quantity that you have in your stock. It has no awareness of how to do some things in your data. So, but we can with RAG, you can augment all these things with a data that is context rich and is accurate. Feed it to the LLM, and the LLM will intelligently respond to you with accurate results. And LangChain is just a framework that used to achieve RAG. So it's a framework that was, I think it was open source in 2021, if I'm right. So it was open source in 2021, if I'm right, yeah. So and it has a lot of libraries and packages that you can use to like perform RAG. So you can use it to augment whatever the LLM is generating with context and use it to derive an actual result. And I'll just quickly show you the workflow of a RAG so that you can understand it better. So you have what we call raw data. Again, it always starts from data. So this raw data is fed into an embedding model. So it's being converted into embeddings. A vector embeddings is then being stored into a vector database. Because now we have a vector database that comprises of our proprietary data. So that means we have context in our database. And from this database now, we can now have a system that we can use to augment whatever an LLM is generating with actual data. And it's going to give us an accurate answer based on our own personal data. So if you usually equate to the embedding model, there's a mistake here. The embedding model goes to the embedding model. Sorry, the query goes to the embedding model, generates a vector embeddings, use that vector embeddings to perform similarity search on the vector database. And based on the output of that vector search, it's going to give back to the LLM. So what we're going to have is going to have a prompt. So you're going to tell the LLM that using this data, answer this question. And the LLM is going to then use that context to then answer the questions, then return that to the application, which is the user. We are going to demonstrate this to bring it home. Because of time, I'm quickly going to walk through this part. So we are going to build something for data engineering community. we're going to build a simple Q&A RAG chatbot. So I thought the best way to bring this home and make us understand this is to actually implement something that we can all relate to. So that means we can implement something that is useful for us and something that reinforces the knowledge. I thought about, can we use our WhatsApp messages? So we have a WhatsApp group. We have thousands of messages. So can we use that to demonstrate how we can augment GenAI with vector databases and build an ecosystem around an LLM that is going to then, use our own proprietary data and use it to give us an output that makes sense to us based on our own data. If you go to ChatGPT now and ask ChatGPT, any question about what data engineering community, it doesn't have access to our WhatsApp chat, but we can augment it and make it give us intelligent answer based on our history of messages. The same thing, and these are the use cases I want you to think of and get out of this message and this webinar is you can then start thinking about your organization. So what are the changes I can bring on board that's going to impact our business by leveraging these cutting edge tools, combining vector databases with some of these already pre-existing LLMs and use it to generate something that makes sense. A lot of organizations are exploring this. One way, my place of work, one way we are exploring this is actually using it for maintenance. So usually when something goes wrong with the production line, there will be technical support where they will have to go through some manuals and use that manual to solve whatever issue that it is with the machine. But with things like RAG, so that means instead of having to search through all the manuals, you can just ask a question like, this is the error message, and it's going to intelligently give you the response. These are the things you need to do. So these are the steps, do this. Then following that steps, make it faster to resolve issues, and it means you can produce more. So we are going to be using our WhatsApp messages. The data is coming from WhatsApp messages, like I said. We are going to give it to an Hugging Face embedding model. From that Hugging Face embedding model, we generate what we call vector embeddings. So the vector embeddings is then going to be passed into our vector database called PyCon. So we'll be using PyCon, which is a managed vector database. So once we store that embeddings into vector database PyCon, remember, what is just a bunch of text, message that I've sent, message that a lot of you have sent in the community, we are going to convert it into numbers, which is interesting. And that number is going to be stored into a vector database. And once you have done with that, we can then use Streamlit. So use a simple Streamlit app. So we are going to use that to query, send a query to what we call LangChain. So LangChain, remember, LangChain is a framework that helps you to perform RAG. So LangChain simply chains together different AI workflows. So LangChain is able to communicate and integrate with different LLMs, is able to integrate with different vector databases, and it has a lot of libraries under the hood that you can use to perform generative AI tasks. So once we send a query to the LLM object, it's going to do an embedding. So it's going to embed our query, convert that text into what we call vector embeddings. And that vector embeddings is then going to be used to search our PyCon database. And once we set the PyCon database is going to return what we know as query results. So it's going to give us relevant results in our database. And with that relevant results, it's going to pass it to the LangChain. So LangChain is going to use that to then build context and use it to send a prompt into an LLM. So we are choosing to use OpenAI. So we are going to use OpenAI GPT 4.0. We are going to test with different LLMs just to see how they behave. We test with Google LLMs and the likes. And once we send prompts, which is the context, remember our context now is our WhatsApp messages in vectors, then plus our query, maybe we ask a question. So those two things are in our context now. So we send that context now into LLM, which is OpenAI. And once OpenAI receives that, it's going to give us results and it's going to intelligently answer questions based on our data and give us response in our Streamlit web app. This is a simple use case that has a lot of applications in the real world that I can start thinking of and how you can, build something out of this. So without further ado, let's get started. Let's get hands-on. I know the time is very much against us, so I'll be quick with my demonstration. So please, bear with me if I'm a bit fast. So before I do this, I'll just quickly demo what we'll be building. So this is simply what we're going to be building. So it's what's it called now? So it's a simple chatbot. It's an intelligence system. And I asked the question in the chat, like, if you have an opportunity to ask our LLM something, so what would be that thing that I want to ask our LLM? And some people already start saying, I'll ask this, I'll ask that. So, but we can already just do some quick checks and just ask anything, and it's going to respond based on the context of our WhatsApp messages. So I can ask something like, the common question that people ask in the community, like, what's it called now? Roadmap. So I can say, give me a roadmap. So I can say, sorry, I can say, give me, what's going on? Okay, I say, give me roadmap. Sorry, my keyboard is actually different. Give me roadmap to. So I can say, give me roadmap to data engineering. This is a common question, and you can see what is going to return. And the interesting about this one is it's not going to hallucinate. If there's anything that it doesn't know, it's going to tell you that I don't know it. That's interesting about this. But LLMs are going to hallucinate and tell you, even though they don't know, they're going to tell you they don't know. But this one is going to be factual and give you something that is real. So you can see that this is the answer now. Very short and precise. You can find the engineering roadmap compiled by the community at the link below. So if I go to this link, it's going to take me to our website, which is our data engineering community GitHub. So all this thing is being collected from our database, from our vector database, and is using that to fetch the relevant results and using that to give me an answer. So that means in the community, if somebody, tomorrow, you don't need to come and ask us data engineering roadmap because you've said it multiple times. Just come here, chat with it, give me a data engineering roadmap, and it's going to just give you you can see how concise it is. You can find the data engineering roadmap compiled by the community in the following link. This roadmap will continue to receive improvements. I remember I sent this message when we first hear about the data engineering roadmap. So you can see the same way it's been said, but intelligently it's responding. So again, I can ask questions like, anything in the context of what we discussed in the past. I can ask, what is data engineering, for example? If we have discussed anything in data engineering, it's going to respond with something intelligent. Yeah, you can see data engineering is field that focus, blah, 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 blah. So somebody must have responded with this in the past in our WhatsApp community. So you can continue to query it, like you can ask it, how can I prepare for an data engineering interview? It's going to respond if there's anything like that. So I'll just do that. A data engineering interview. So if you discuss anything in this context, it's going to respond with how you can prepare for a data engineering interview. You can see. So definitely we've discussed this in the past. So to prepare for a data engineering interview, you can follow these steps. So it's going to give you these are the things that we've discussed in the past in our chats. So like that, you can ask multiple questions. And this is just a simple use case, just converting a WhatsApp text messages into something that is now intelligent that you can then use to augment whatever. So rather than asking some question in the community, you can just come here and just ask a question and you get the answer. And this is not going to hallucinate. It's going to, if I ask anything that it doesn't know, it's going to tell you I don't know. For example, if I ask what is the capital of Nigeria, if you've not discussed anything about this before, it's going to tell you I don't know. Oh, it's Abuja. He knows this one. What can I ask? Let me say, what is accounting? It seems this is intelligent more than I thought. What is accounting? Yeah, this one is saying I don't know because it's not in the context of the message that we've given the LLM. It's not, I don't know. Just that I don't know. It's not going to hallucinate and give you something that is wrong. And just to quickly demonstrate, because of time, I've prepared a notebook, which is an interactive way of discussing so that I don't have to type and waste our time and, get into issues and stuff like that. So this is a simple notebook. I'm going to share the GitHub link. So let me just grab the GitHub link. So I've prepared a proper. So I'm going to grab the GitHub link. So this you can go through it while you're doing this. So this is the notebook. So I've created a proper documentation on things you need to different things overview, how to build it, the architecture diagram, tools used, and how you can do this. And the important part is even these use resources. So these are a lot of resources that you can use to get up and running, building stuffs. So I've also explained how you can build the app, and this I'll drop it in the chat. This notebook is just an interactive way how you can build the application. So because of time, I'll walk us through it and I'll open floor for question. Yeah, so you can go through it, and while I go through it as well. So, and if you find it useful, remember to give it a star. Yeah, so I'm using Google Colabs for those of us that are not aware. So I'm just using this to leverage Google's resources. So, and I've explained, I've made it very explanatory. I've added comments, I've added descriptions so that we can understand how it's been done. But at a high level, just to walk us through what we are doing, you get the benefit of this when you read through it because it's highly self-explanatory. So what we are doing is just installing the necessary packages, just the normal we write a Python code. PyCon is our database. So it's a library in Python that we use to interact with PyCon vector databases. So this is PyCon vector database. So you can see this is my vector database account. These are the different indexes I have. So if I click on any index, it's going to give you like the different things that you have there. So I interact with it via an API. So the API is interacted with using, excuse me, trying to get back to this space. Okay, yeah. So using API. So yeah, that's what PyCon is. And LangChain community, remember, LangChain is the framework that used to build RAG application. And the LangChain community is actually the version of LangChain that has the community integrations to different tools and third-party tools that used to build AI applications. LangChain PyCon is how LangChain is able to interact with PyCon, which is the vector database. LangChain Hugging Face. Hugging Face is like Docker Hub. So this is a hub whereby different people, upload their model, and you can also use people's model to work with your own applications. You can also upload the data sets. People can upload data sets. So it's just like an hub. So and this yeah, this is Hugging Face. So these are different models. So this is Hugging Face hub. So you can have different models doing different things, and you can use API to interact with all these models and use it to perform your task. So what we are doing here is we are also installing Hugging Face package that we use to interact with some models on Hugging Face Hub. So then we have launching OpenAI. So this is what you're going to be using to interact with OpenAI LLM via an API as well. So the reason why I have Pydantic here is because I was having issues with some dependencies, and some of the packages require Pydantic of this version. So that's why I've pinned the versions to this one. If not, it's not necessary. So the first step we do is, you can import our WhatsApp messages. So these WhatsApp messages, just to give us a glance of how it looks. So I'm going to import it here. So we're doing that. So this is so let me know if you can see my Excel. Why is this? Why is this not showing? Interesting. So sorry, I can't bring my Excel to this screen. But yeah, I'll continue regardless. So, but the WhatsApp messages is just a clean data set. This was extracted by Joe. Joe extracted these WhatsApp messages from the inception till I think the cutoff date is December 3rd. So while we're trying to do some cleaning in the group, and these messages is then being cleaned and passed and converted into like proper messages. So in a CSV format. So what we are doing here is just importing that Excel. So I'll just do a quick scan so that you can see. So using pandas, we are using pandas to read the CSV. And what we are doing here is we are just trying to we don't need all the data in the CSV. We just need to get the sender who sends the message and the message itself, which message is being sent. So by concatenating these two, we are combining it to just one series. And the reason why we're having as type here is because we want it to be string. So that being said, I can just pick a sample. So this is just a sample of the data, just starting from index 4 and ending at index 6. I want to see a sample of the data. So if I run this, it's going to give me like the messages from that CSV data. So you can see the message, hi everyone, you are welcome to the Tangerine community, blah, 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 blah. So this is one of the message in the WhatsApp messages CSV. When that is loaded, remember, this is just a sample, just 2 messages so that we can understand how everything works. Once that is loaded, we then have something we call generating embeddings. So that means this data now, it's very difficult to process and to make intelligent. But to make intelligent, we need to generate something we call embeddings. So we need to convert it to like a vector. And to do that, we need to import what we call Hugging Face, LangChain Hugging Face, which is an embedding model. And we can then get a model from Hugging Face. So this is a model name. So if I show you here in the model I shared here, so you can see there are different models. So, and you can just pick the one that works for you, depending on how great it is. So the one we are using here is all mini LM LCV2, passing this to a model object, and you can then use it to generate embeddings. So if I run this part of the code now, if all is well, okay, so I need to rerun this part. so that we'll install the packages. Because of time, I will just walk you through it, and yeah, we can interact with it later after the call. So what we are doing is we are just generating embeddings here. So I'll hide this one. So we are just generating embeddings here, and let me see if this runs so that I can. Okay, so let's me run this one. So this is going to generate embeddings. So I just want to show you how it looks like. It's going to take time because it's the first time. It's going to install the necessary things, build the packages, and then use it to generate embeddings. If you look at this place, you can see that it's running some processes behind the scene to generate the embeddings. So, but again, I'll just continue. Once the embedding has been generated, we can then store the embeddings. We need to store the embeddings into a vector store to make sense of it. So you can see it's now doing some sentence transformer, doing some encoding, and it has generated embeddings for this text. So this text now that we are seeing here has all been converted into these vectors. So you can see the vector equivalent of what you've seen there is this, using an embedding model. So it's represented as numbers. So that means these numbers now, we can now use it to represent different things. So, but we can see that we only have just 2 messages, but we can see from here, we have 384 rows. So these 384 rows simply means dimensions. So this has been converted to 384 dimensions of a dimensional vector to represent that text of data. Now, what that is done, we can initialize our index in a vector database. So the vector database we are using, like I said, is going to be Python. And if we're using Python, we need to have like an API key. What I'm doing here is just using Collab way of passing secrets into our notebook so that we don't expose our secrets, best practice. So Python API key is an environment variable, passing it here to initialize my Python index. So if I run this one, so this is going to create an object, a vector database object, PC, and I can then use this one to initialize a vector store in Python. To do that, you need to create the infrastructure, and this is where we need to specify which cloud platform and which region you are running infrastructure on. So if I run this one, this is going to create this index now. It's going to create it. It's going to store it on a variable on this variable, and it's going to be used to create a vector index on Python vector database. So this part of the code is where we are deleting. So we are checking if this vector name already exists, this vector index already exists in the database. Delete it because we want to create a new one. And here we are just checking if the index is not in this list. So you can use these parameters to create a vector store. So you can see I'm specifying the metric is cosine. Remember the similarity measure we mentioned the other time. So cosine means it's going to use the angle between 2 vectors to determine their similarity. And dimension simply means how many dimensions you want to use to define and represent the data set. So when that is done, we can then connect. So we can connect to our database and describe. So this is just describing how many records we have in our index. So you can see the total count now is 0 because it's a new data that it's a new database we created. There is nothing there, but we can begin to add data into it. So if I run this part of the code, again, all this is being explained in the vector, in the notebook. So if I run this part of the code, what we are doing is we are using this to store those generated embeddings into the vector store. And we are doing that using a vector store from Python vector store, which is an object from LangChain. This is a LangChain function that we use to interact with Python. So this vector store object now is an instance of this object, and we can then use this one to begin to interact with our vector database going forward. So again, remember we create our database here, and we only have 0 records. So let's check if something has been inserted. So we call index.describe to see if anything has been inserted into our vector store. And we can see that we have 2 records before we have 0 records. So yeah, once we have this set up in our vector store, we can begin to query the database and see if it's going to give us an answer. So, but before I do that, I'll show you the data again. Remember, this is the data. We have the data that says we have less than 20% response to this survey so far. So this is part of the data in the WhatsApp messages. So if I go to this part now and I query the vector store, so say this is a query. How many percent response do we have in the survey? Because we've stored data in a way that context is being identified. If I run this part of the code, this is going to go into the database and it's going to give me the list of vectors that matches what I've queried, and it's going to return the necessary text, just verbatim as it is in our data. So you can see this has been returned and it's ranking it saying, good morning, good afternoon, or we have less than 20% response. So this is what is actually in the data. But because you understand the context of what I'm asking, it's going to return what is relevant to me from the vector database. And again, this is the Rackflow workflow implementation. So because now we now have a vector store, that means you can now augment that data using that vector. You can use it to augment our LLMs to then use it to build something intelligent so that it doesn't just return the verbatim text to us. It's going to return it to us in a conversational way so that we can feel like we are interacting with someone and it's going to intelligently respond to us. So, and to do that, we need to just import the necessary library again, LangChain Hugging Face, there's the embedding model. What I did here is to just test with different models. So I test this one. This one is from Hugging Face. I'm using the Falcon 7B construct. So this is a model trained with 7 billion parameters. For it to have something meaningful from an LLM, it should be at least 7 billion parameters in terms of the parametric knowledge. Yeah, so just using it to test. Then I have something here as well for Google model, but the one I'm going to show you is the one from OpenAI. So the one from OpenAI is the common GPT 4.0 meaning. So this is one you see when you're interacting with GPT on OpenAI ChatGPT platform. And using this GPT now, I can now ask it questions based on my data. Even though it's not aware, it's not trained on my data, I can now pass that data into GPT mini and it's able to then use it to form context and use it to respond intelligently to whatever question I'm asking. So what we are doing here is we are just creating like chat OpenAI. So this itself is a class from, you can see we are collecting it from this LangChain OpenAI package, and it serves a class, and we're just instantiating an instance of that class as LLM. So passing the necessary model name that I want to use, this OpenAI key, you can generate it from OpenAI platform. Using this, that means you can then use this to then ask ChatGPT or again LLM, not ChatGPT, the GPT LLM questions based on our data. And what we are doing here is we are only passing the context. So we are passing the context of our data into the LLM and using that, we're using to generate output, which is response into our query. So rather than having something here, remember when I ask the same question here, how many percent survey we have? Remember what is responded is just the verbatim data that we have in the database. But after I pass this to an LLM and I'm asking the same question, how many percent survey, how many percent response we have to the survey, it's able to then answer intelligently, say we have less than 20% response have been received so far for the survey. So you can see that this is now intelligently responding to what we have done. So, and this is just like a demonstration of what is behind this chatbot. That's the workflow. But for me to build this, it has to be like, it can't be on notebook. So it has to be like proper implementation whereby you then deploy to Streamlight. But this one is just a walkthrough which you can go through at your own time, use it to understand how you can augment LLMs with rich context, fast and accurate data sets, and using that can use it to create something intelligent for yourself, for your organization, or even come up with a product that makes sense to you and other people can benefit from. I know I've gone way, way beyond time. I'm sorry about that. I just, I mean, there are a lot to cover, but I'll stop here and I will hand over the mic to Blessing for question and answer. Thank you so much, everyone. I've shared the GitHub link. Look to it, read more on it. There are some resources under it. You can also try it on your own and see how everything works. And if you have any questions, I'm always in the community. You can reach out personally, or you can also ask questions in the community, and I'll be happy to answer you. And again, if you find the repo useful, give it a star. And yeah, over to you, Blessing. I know I've taken too much of your time. I'm sorry, but I hope everybody has been to learn and gain from this. Thank you.
All right. Thank you so much, Najeeb. That has been like a very, very insightful session. Please, I'd like to confirm if you can hear me. Can anyone hear me?
I can hear you, Blessing.
All right, so thank you so much, Najeeb, for that very insightful session. And thank you for taking us through the basics and bringing us to this point. I am sure that, I mean, have been writing since you started, and my paper, my notebook is just almost full. Thank you so much. And thank you for sharing, for deciding to share your notebook with us. I'm sure that a lot of people would want to go through that and then ask questions. All right, and I must also thank everyone on this call for staying put till this time. Thank you so much. In as much as a part of me feels like we should keep going, but then again, we'll have to go. So thank you so much, everyone, for joining our Demystifying Data Engineering series today. And thank you also to you for staying till this time. If you have any questions, please always ask your questions in the community. And I don't think that this session would end without encouraging you to follow us on all our social media pages. So follow us on LinkedIn and on Twitter. Just follow us on LinkedIn and Twitter. Yes, and then join the community, interact, and you can always ask your questions. All the resources that the facilitator has spoken about, that he's going to share them, he is going to share them. Thank you so much, everyone. I think we'd have to go now. I don't know if the facilitator has any final words.
Yeah, I mean, final words from me is to, again, don't let it end here. I always say this. There is huge potential. Data engineering, I mean, we are blessed. For anybody that is a data engineer, we are blessed. We are so much blessed because whatever happens, data is the foundation. And whenever data is the foundation, data engineers have something to contribute. And we just keep exploring, keep seeing, building perspectives and not just moving data, trying to understand how things are going, things are evolving. Every now and then things are changing. So let's keep being curious, being open-minded, not being restricted to say, oh, this doesn't concern me. But as a data engineer, you have to be like, in a way, a generalist, somebody that is able to build perspective from different things so that you can be able to collaborate, you can be able to initiate things, especially if you are planning to become a leader. You want to lead a team. So you can't lead a team with just your data engineering experience, because usually you have to have a data analyst, a machine learning engineer, a DevOps, in a team, and you are leading a team and the only thing is just to use AirByte to move data from A to B. It's not going to help you. So if, I just want to inspire us to keep pushing, keep learning, keep expanding our horizon, keep building perspective so that by the time we have that opportunity, we are much prepared to be able to implement something that is not only going to, help us as a person, but it's going to contribute to whatever business we find ourselves, whether personal business or working in an organization. So again, let's take it forward. What I've shared, the GitHub link I've shared, it has everything you need. It has the interactive notebook that is well detailed. It has the code itself that is behind the WhatsApp chatbot that I've displayed. It also has documentations for everything you need to learn about vector databases. There are YouTube links as well if you like to watch videos. So everything you need there is fine. And if you need anything or you have any questions, please reach out and I'll be more than happy to support you. Thank you so much, everyone. And it's a pleasure to have shared my knowledge with you all today. And I hope we'll learn something and we'll continue to grow and learn together. So thank you, everyone. Thank you so much for listening.